Hey guys, go ahead and get out your note sheet for normal distribution and the bell curve. So a normal distribution is a bell-shaped curve that's symmetrical, and it's defined by the mean and standard deviation of a data set. So you can see a look at what a bell curve would look like down below, and basically it's a way to compare data to the mean, and you'll be able to see where the typical people would perform, average performers. People to the right of the bell curve beyond a certain point would be considered your high performers, and to the left beyond a certain point are your low performers. So this isn't on your note sheet, but this is just describing what normal means in terms of a bell curve. So some examples of data that would closely follow a normal distribution would be IQ scores, heights of people, blood pressure, and test and quiz scores. Basically where you know you're going to have your average, then you're going to have your above average and then below average data for these kinds of things. IQ is probably one of the most popular that's seen as a bell curve. So in order for us to construct and analyze bell curves, you have to know what mean and standard deviation of a data set would be. And mean is the same mean that you've learned in the past. It's the average of a data set, and it's found by adding all of the numbers and dividing by the amount of numbers that you have in your data set. Standard deviation would be something new for you guys, and it's basically a measure of how spread out numbers of a data set are from the mean. So it's kind of putting a number to a distance from a mean that you would have. And basically what we could say is that the bell curve tells you how you compare to the mean using standard deviations to measure. So again, standard deviation is kind of like your measurement, kind of like inches or feet, but standard deviations refer to when you're measuring from a mean on a bell curve, and we know what you can be either above or below your mean on the bell curve. So we're going to go ahead and fill in everything we know about a bell curve on your blank one on your note sheet, and I do want you guys to start with writing down what these little Greek symbols mean. So the one that looks kind of like a U actually is the symbol for mean, and then the one that looks like we always call it a flying O, is your standard deviation symbol. So on your bell curve, if you locate these, the very, very middle is your mean. So if you want to also label that as mean, but you can use the symbol as well because you will see a lot of these as we go through statistics unit. And then from your mean, since again standard deviation is how you're comparing yourself to the mean, to the right of your mean you've got your positive standard deviation. So we have +1, +2, +3, and then to the left you have your -1, -2, -3. So above average would be anything to the right of the mean, below would be anything towards the left of the mean. And again, that standard deviation is just a way that you compare yourself and measure yourself to the mean of a specific set of data. The next thing I want you guys to include on your bell curve is the percent in each of these sections. That in a typical normal bell curve, this is the percent of the data that you would typically find within these standard deviations. So within one standard deviation of the mean, and that's going to be to the left or to the right, so within one is about 34.1% on each side, which is typically about 68% of your data. So the majority of your data falls within one standard deviation of the mean. Once we go out to 2 standard deviations of the mean, you add an extra 13.6% on each side. So if we were to kind of roundabout way add all of that up, that's about 95% of your data at that point. When we go all the way out to 3 standard deviations of the mean, you're going to add that extra 2.1% in each section, and that's going to make up almost 99% of your data. And then you've got very, very few amounts of people or things that would fall beyond 3 standard deviations. That's kind of your way, way out there, either highly above or highly below whatever kind of data we're talking about. So here's those percents again. Again, we said that within one standard deviation, and that includes positive and -1, it's about 68%. 2 standard deviations goes up to about 95% of your data. 3 is about 99%, and very few, like I said, would fall beyond 3 standard deviations. So once again, just to kind of summarize, a bell curve shows you how you compare to the mean using standard deviations to measure, and we talked about that you can be above or below the mean on a bell curve. And then if you wanted to find your specific spot of where you would be on a bell curve, you can actually calculate that by finding what's called your z-score. So, not everybody's going to be exactly 1 standard deviation or 2 standard deviations below. You might be 1.2 standard deviations above, or you might be 0.05 standard deviations below the mean. So that z-score is a way of finding your exact spot. And this is a look at IQ scores, and this is actually real. The average IQ score, the mean is about 100, and then anybody above that that, starts to get above average. Anybody below is a little below. And then you can see where Einstein was. He was 160, so he was well beyond 3 standard deviations above the mean, which is very, very few people that would ever have IQs that high. So he was exceptionally gifted. So the definition of a z-score is a way to calculate how many standard deviations above or below the mean a raw score is. It's basically, again, a way of finding your exact spot on the bell curve. And we know positive z-scores would be when you're above the mean or to the right of your middle or mean line. Negative z-scores are below the mean or to the left of it. We have a formula for z-score. This actually will be given on your formula sheet when you take your SOL, but you can see your formula on here, and again, we have these same kind of symbols we've seen earlier, and we're adding an x, and x just stands for a data value. It's just the number you're trying to find the z-score for. Your mean, again, is that, we call it the crying U, I guess, because it looks like a teardrop, and then your standard deviation is the flying O, and then Z stands for your z-score. So this formula can be used to find anyone's z-score if you know what the mean and standard deviation of a data set are. So we're going to go ahead and tie this all together and look at some practice problems and how you're actually going to see these problems whenever you take assessments. So the first thing we're going to look at is data from an algebra test, and they tell you that the mean score is an 83% and your standard deviation is 6. So we're going to go ahead and label this blank bell curve so we have all the information we need. If you didn't have one drawn for you, you would want to sketch one first and then go ahead and get your labels in to help answer the questions. So with a mean of 83, we know again that that middle line is your mean. And then we know that your standard deviation here is 6. So that means that every time you move to the left or right of the mean, each of those next lines would be 6 spaces away from your mean. To the right is a positive 6, so we're going to go ahead and add 6. So 83 plus 6, 89. Then 95, and then 101. And then when we move to the left of our mean, we're going to subtract 6, which is going to give us 77, 71, and 65. So seeing those numbers in place definitely helps to answer the questions we're going to have. We're also going to go ahead and fill in those percents because, again, that also helps whenever we need to analyze and answer questions. So go ahead and fill in the percents on your bell curve, and in the future, if you want, you can just call it 34% for the first standard deviation, 13.5, probably a little easier to remember, and then 2, and it still gives you the same percents when we generalize what each section represents. So let's take a look at number 2 here. We're asking for what percent of the values are within the interval of 77 to 89. So if you look at where 77 is to 89, you're basically just kind of adding those up. That's also the one standard deviation, so that should be about 68% of your data there. Letter B wants you to look from 71 to 95, so if we extend, we're going to 2 standard deviations. That should always be about 95% of your data. And then lastly, we're going from 65 to 101, which is your 3 standard deviations, and that's almost everything. That's about 99%. So if this were your algebra test, you can expect almost every single person to get between a 65 and 101. Number 3, what percent of the values are instead of inside, but outside of the interval 77 to 89. So there's 2 ways you can do this since we've already done 2A, and it says the percent that are within that was 68. The percent out is whatever 100 minus 68 is, or you can just generalize beyond 1 standard deviation, take away 34% from each side and see what you're left with. And that should end up being about 32% of the data is outside of that interval. Letter B, outside of the interval 71 to 95. Well, again, since we know in that interval is about 95% of the data, there's going to be about 5% of people who scored below a 71 or above a 95. And then letter C, what percent would be outside of 83 to 101. So this one's a little different. It's not 65 to 101. So if we look here, here's where 83 is, here's 101. And basically that's taking an entire right-hand side of the bell curve. And we normally have about half and half, 50%. Well, we do have half and half, 50% on each side. So we're going to just go ahead and say that's going to be about 50% of your data right there. I know we're not including that beyond 3 standard deviations, but remember that's such a small number that we can still generalize and say that's going to be about 50%. For questions 4 and 5, we're actually going to calculate someone's exact spot on the bell curve by finding their z-score. And again, for z-score, you would need to know what the standard deviation and the mean are, and we already know that, 83 and 6. So we're going to go ahead and just use that z-score formula to find these. So for number 4, if you had a 92 and you wanted to see what your z-score was, you would take your formula, and again, it is your value or the data value you need, which is 92, minus the mean, which was 83, divided by the standard deviation. And you do have to make sure you're careful with this on your calculators if you use it. You have to do 92 minus 83 and either have parentheses around it or hit equals first and then divide by 6. So we end up with 9 divided by 6, and if you divide that, you end up really with a 1.5 z-score. And it's positive because, again, this score is above the mean. You can kind of generalize before you even do this that a 92 would be, right about here in between 89 and 95. And if you actually do the math, it's exactly halfway between 89 and 95. And since 89 was that +1 standard deviation and 95 was +2, and you're halfway in between, then obviously you would be at 1.5. Number 5, so if you want a z-score of a 75, so if we first kind of look at the bell curve, that's just going to be a little bit below 77. So what we can be thinking already is that is in between the -1 and -2 standard deviations away. So your answer should be -1 point something. So we're going to again use that formula. You're going to take 75 minus the mean of 83 and divide by your standard deviation, which is going to give you -8/6, and if you divide that through, you're going to end up with about -1.3333, -1 1/3. So again, we knew we were going to be between -1 and 2, a little bit closer to -1, since 75 is closer to 77 than it was 71. So it's definitely good to see this bell curve and be able to visualize where that score is and then calculate the z-score to kind of make sure it makes sense. And then with number 6 and 7, we're still going to work with z-score, but this time we're going to look at questions a little differently. We're going to look for the percent that would produce a z-score of -1.5. So we already know the z-score value. We want to know what your percent was if that was your z-score. So once again, you're actually using your z-score formula. You're just doing it a little different. So you know the z-score this time, so we're going to plug in -1.5. What we don't know is the data value, so we have to keep x as x, that number we're looking for. Minus your mean here, which would have been 83, and divided by your standard deviation of 6. Something to keep in mind with this, since we know it's a -1.5, again, if this was your -1 standard deviation and this is -2, some of you could probably actually figure out what halfway in between those would be. That's going to be -1.5. But if not, you just solve this equation for x. So we're going to get rid of 6, multiply both sides by 6, leaves us with x minus 83, and then we're going to go ahead and add 83 to both sides. And that's going to give us that score of x equals 74. So if you had a 74% on your test, then your z-score would have been -1.5. Again, you could have probably visualized that halfway between 71 and 77 would be -1.5 and just looked at the bell curve this way. But if you don't have this drawn, you can just use the equation and solve it that way. Number 7, what percent would produce a z-score of 2.3? So again, if I kind of start to visualize where that's at, 0.3 is a little harder to figure out on your own, so we at least know it's probably going to be somewhere around here. So if I had to guess, probably going to be like a 97-ish maybe. So we're going to go ahead and use our z-score formula. So this time we know the z-score is 2.3. We're solving again for x, minus your mean over your standard deviation. And then we're going to work backwards and solve for x by multiplying both sides by 6 and then adding that 83. Final answer here should be about 96.8%, maybe even a 97%. So that's it for now for bell curve and z-score. The main takeaway from today is just understanding what a bell curve is, what it looks like, your percents and your breakdowns, and that a bell curve is really just a way of measuring how far something is in standard deviations away from the mean to put a value to it.